Good afternoon to all. Yeah, all the students now we know very well we are going with the what actually yes the lecture number 1, sorry, unit number 1 and the lecture number 2 we are completed. Okay, now just the IIT advanced practice somewhat sheets are there once you tried here. Okay, now we are going with the what the next concept lecture 3. Okay, yes, why? Because every answer is given by me only, you are not doing anything. Okay, now once you read it the total lesson, okay, now and take help of level 1 and level 2 answers whatever there. In that one there is somewhat answers are there, whatever IIT foundation, IIT advanced practice sheets are there. You may not ask any questions to me, you are not given any task to me. Yes, so many times ask you if you have any doubts or otherwise any answer is required for you. Yes, you not said anything. Okay, now that's why this time you have to do that IIT advanced whatever the things are there. Okay, now why? Because it is very familiar to your sixth lesson. Yes, of general academics, whatever matter it's a pure. Yes, so much components are coming into in this lesson from that particular lesson only. The last class also we are already discussed. Now all the students, I hope you understood everything of that lecture 2. Now we are going to the lecture 3. Yes. Yeah. Now there is taken a rate of expression of rate law. There is so many things we are considered here. Yes, the expression or equation. Just especially there is in this component we are going with the what about the rate constant especially. Got it or not? About the rate constant we are going now. Okay. Here, what is the thing? Rate of rate expression or rate law? The last classes we are discussing what is the effective factors of rate of reaction. Okay, now which one is called rate law and for how we consider the rate expressions actually. Okay, that is a very important and it will be utilized for how much concentration of the products are required, how much concentration of the yes reactants we are take it is into the chemical reaction and which type of catalyst we are required to use. Okay, now and how much temperature we have to provide for a completion of rate of reaction. From where these all the things are coming from this particular. Okay, now rate of expression and rate loss only. Okay, now there is a one technique how to find out the yes that the rate loss actually. Okay, clear or not? Yes, what is that? The expression or equations that what is that correlated the rate of reaction with the concentration of reactant. It is only known as yes the rate or rate law or rate of rate expressions. Got it or not? Yes, whatever the equation that correlated concentration with the concentrations, whatever the concentrations of reactants are there, whatever the concentrations of products are there, that will be all we take account. Okay, that will be only gives for us rate reactions and expressions for us. Okay, now what is example you have to take here? Yes, suppose you take here A into A plus B into capital B is the product still. Okay, clear or not? Suppose how to we are find out the rate law and rate constant and all these things. This is the first reactant. This is the second reactant. Okay, last we have taken two reactants in a chemical equations or not? Yeah, these two are the reactants we are considered. What is this A? What is this capital A? What is this B? What is this capital B? Okay, clear or not? That is only now we are going to consider here. Now, the rate law, the rate expression we are written like this actually. The rate of this above expression is a right like this. Yes, that is only K into concentration of A to the power of A and concentration of B to the power of B. This is the gives for us what rate expression. Got it or not? Yes. I hope you understood. There is what is this A? First product name. What is this A? Sorry, first reactant name. What is this A? This A is indicates what actually. Yes, this is the what is the order of A and as well as B. You know very well, already know very well, the rate is directly proportional to C to the power of N. Okay, now from this one only we'll consider it is. Okay, clear or not? It is also written as R is equal to K into C to the power of N. Got it or not? In the last classes we have discussed what is this K? K is a rate constant. Okay, this is only called what? Rate constant. T is the what? A concentration. N is the what? Order of the reaction. Here also the same thing we have considered. This is indicating the what? Concentration of yes reactant. This is indicate the what? This is indicate the what here? Order of the reactant of that reaction. The K is the what? Rate constant. Okay, clear or not? Yes, these A, capital A and capital B are indicates of what? Yes, these are indicate the concentrations. Okay, clear or not? How much concentrated of that reactants? That is only we are consider here concentration of the A and B. Okay, clear or not? Of A and as well as the B. Yes, and small a and B are what? Order of reaction. These are indicating the what? Order of reactions. And as well as there is a next one. The K is indicate the what? Rate constant. It is indicate the what? It is indicate the rate constant. Okay, this is only gives for us what totally as expression of the rate or it is only called the rate law. Okay, clear or not all the students? Yes, whatever the concentrations are there and whatever the order of the reactions are there, that will be combined together when we written. That is only indicate the what rate law. Okay, now please note down the rate law. This is the called the rate law for this type of a general form for the rate law. Okay, clear or not? Please note down it. I hope you got it. It is next. Suppose how we write the rate law for the somewhat reaction general form the given here. Yes, what is the rate law? There is the correlated. Yes, we just to take the correlation of the rate of reaction with the concentration of the reactants. Okay, now whatever the correlation there between the concentration of reaction to the rate of reaction is only called what? It is only called what? Rate law. Write the expressions or equations right between the correlations of the what here? Concentration of the reactants and as well as the one more thing is what? Concentration of the reactants and as well as the rate of reaction. The correlation between the concentration of the reactant to the what? Rate of reaction. These are the concentration of the reactions. This is the rate of reaction. Whatever the correlation, write in the form of expression, that is only we treated as rate expression or rate law. Okay, clear or not? Just somewhat general forms we are considering. Suppose sometimes there is a catalyst are produced with simply okay na one product. There is no rule of the two reactant every time. Okay, clear or not? Yes, already I am discussing with you. Suppose you take H2O2 under the catalyst of manganese oxide, it become what actually hydrogen and carbon are the oxygen gases. Clear or not? These type of the things are okay. Now gives what for us somewhat rate expressions. How we write the rate expressions or rate law for it. Okay, simply the rate of reactions, that whatever the rate of reactions we are taken, it is R. R is equal to, I am simply write it is a K into A. What is this K? Concentration of this reactant. That's it. Yes, for this one, I want to write the rate of reaction. There is the K is a constant. Okay, now, and as well as I want to write H2O2, concentration of H2O2. That is gives the what? Rate law or rate expression. Got it or no? This is the one type of a general form. When there is a one reactant is only there, that order of reactant in case is the one. Got it or no? Yes, now order of reactant is how much here? One only. Next, after this, there is the general form only. Already we written A plus B gives it the product. How write that there is a rate of reaction for it. Now R is equal to K into concentration A. We written like this. Got it or no? Now, how you write this is the rate of reaction for this type of a chemical equations, for this type of a chemical. Yeah, it is right. It is as R is equal to K into concentration of A. Okay, now into concentration of the B. Got it or no? Yes, this is only the simple concept. There is a what is the A here, what is the B here? Already one and one. That's why there is a power is a one only. Got it or no? That is we have to write here. And next, after this, suppose I am taken here A plus 2B is somewhat product. How we write it is rate of reaction for it. R is taken as what is that K into A to the power of 1 only, B to the power of what it is there? 2. Order of reaction, how much they given? 2. That is why you have to write the 2. Understand all of you? Write in this particular expression form. Write in that particular equation form. This is only called the what? Rate of reactions. These are called what? Rate of reactions. Yeah, please note down these general formats also. It's important for you. Yes, for understanding purpose. Yeah, there is somewhat solid examples that are given. From the solid examples, we get an idea what the type of questions are may come from in this particular concept. Okay, just listen here now. Yeah, what the things are given here? First example here they given. What is the example? Write the rate law for the following reaction. Write the yes rate law for the following reaction. What the reaction they given? NO2 they given here. Okay, clear or not? NO2 they given here, and as the last plus F2. Okay, gives rise NO2F plus F. Okay, clear or not? This is the called what a slow reaction it is. Okay, now they given like this. Next, this equation is also written as actually it is not it is required only product based only. Yeah, there is a what they given NO2 and F2. Okay, now the concentration, the rate is written as simply it is equal to K into NO2 and as well as the F2. Got it or not? This is only the rate of this equation. Got it or not? Any doubt here? Simple thing only. There is a don't go any other misconception. Simple general form. You concentrate on the general form. A into A plus B into B gives whatever the product and as well as whatever the reaction nature they given. Okay, now in case there is a exchanges the order of reactions, automatically the powers are changes. When the order of reaction is exchanges or when the concentration is exchanges, automatically rate of reaction is also may exchanges. Got it or yes? In this way only we are considered the rate of reactions. Got it? As I hope you understood this. This is the example number one they given. And next example number two, once take it here. What they given in example number two? Write the rate law for the following reactions. Whatever the reactions are given, yes, there is a simply the given what N2O5 gives rise, okay, na, NO2 plus NO3. That is whatever the products are found, that is not an issue of rate of law purpose, rate of reaction purpose. We concentrate on only rate of reactions, expression or rate of reactions, and as well as reactants only. We want to write the rate law or we want to write the rate expression. You should concentrate only on the what reactants, its order of reactants, it's a concentration of reactants. That is only the three concepts. And now there is a what it is the rate is equal to taken as the concentration of N2 O5. Why? Because the order is only one. Okay, now there is no other reactants are there. It looks like a what A gives rise the product it is. It's simply the general form for it is the one A gives rise product. At that time, R is equal to what we written K into concentration of A. That's it or not? Yes, this is only the concept of rate of reactions. Yes, all the students, next to whatever the problem is there, it's somewhat difficulty thing is there. Okay, now next solid example C, that is somewhat difficulty thing is there. First, we note down this, we'll go with the next level. Yeah. Yes, there is a whatever the example it is there, what it is difficult it is there. Okay, you need to read every line in that. Okay, clear or not, all the students? You have to read every line in that. Whatever the lines are there, you have to yes read it. Yes, first thing is the given one reaction as what 2A plus B plus C. These are the reactants are given. Okay, now yes, whatever the products are there, it cannot be part of first, but you have to write B plus and as well as the 2E. Okay, now yes, the question is what you know is the first order with respect to A. Okay, now clear or not? This equation with respect to A it is in a first order, and of a second order with respect to the B. Yes, of zero order with respect to the C. Okay, now yes, you want to change that equation totally. Okay, now the given equation is this one, but it is a first order with respect to A, a second order with respect to B, and zeroth order with respect to C. Find out rate law for the reaction. First, you have to find out rate law for the reactions. Okay, now whatever the given for this is, you have to find out the rate law, whatever the given orders purpose. Okay, then next second question is what you know. If the concentration of A, comma B and C are doubled, then calculate the new rate of reactions. Okay, now yes, now there is a totally it is a changes. Okay, first you have to write the rate of reaction for this hypothesis. What is the rate is equal to? The rate is equal to taken as what is given here? A to the power of 2 and as well as k into a to the power of 2, yes, and b and as well as the c. The given for a given thing. Okay, for a given thing it is only R. And there is a what order for it is a 2 for 2, it is for 1, it is for. But here A order is what? A order is what? According to given formula 1. Okay, B order is what? They say. Okay, now B order is a 2. B order is 2. Okay, clear or not? And what is C order? 0. C order is 0. Then this is become what? Yes, then equation become what? Then equation 1 becomes is a become as rate taken as k into a to the power of 1, b to the power of 2, c to the power of 0. What it or not? For a given things. Okay, whatever the rate we are considered for a given things, it will be taken from what? R1. R1 of rate is equal to k into a to the power of 1. Then they given order 1. Okay, clear or not, all the students? Yes, and as well as when they given order 2, it is okay. Now, yes, then the order is changes here. B for 2 and 0 order with the respect to C. In the problem they given already. And now we have to find out the rate law of reaction. This is only become the what? Rate law of reaction for the what? For a given thing. Okay, clear or not? For our first answer, yes, this is only the first answer. Yes, what is the first answer? The rate law for a given order are this. And next second one. What is our second answer? Second one. What is the second? It is one second. What they given here in a second one? If the concentration of the A, B, and C are doubles, there is now a change in the orders. Okay, clear or not? Now first one we are changes orders. The second one now we are changes to go. Yes, what we have to changes to go? Yes, concentrations we have to changes to go here. Okay, we have to changes here concentration. Okay, how we changes the concentration? Look at that. There is a yes double we have to make it. Given rate R1 is equal to become what now? Here R1 is equal to yes k into A B to the power of 2, C to the power of 0. Okay, these are only there or not? Yes. Given that concentrations are double. What is the here? The concentrations are double. Understood not all of you? Yes, and now there is the whatever the A it will be there, it is replaced with the 2A, and B is also replaced with the 2B, and C is also replaced with the 2. Okay, concentrations only become double. There is order is the same. That is why the rate rate R2. Suppose it is equal to taken as what? The rate R2 is equal to 2A to the power of 1. Here we are what taken? K into 2A to the power of 1, 2B to the power of 2, yes, and 2C to the power of 0. Okay, clear or not? There is everywhere 2 into 2 into 2. These are the S components we are there now. That is why there is you have to take 8 is a comes into we written as A to the power of 1, B to the power of 2, and C to the power of 0. And R2 is equal to taken as 8K into what is it looks? It looks like this or not? Like this or not? It is written as R2 is equal to 8R1. What you understood from this one? In case we want to change the double concentration, the rate of reactions are increases the what? 8 times than the first initially whatever we take. The concentration make double. In case there is a 3 products are there, the product number is also important. At that time it will become 8 times. Only 2 products are there, 4 times. Only 1 product is there, double. Got it or no? Yes. What you understood from this one? 2 to the power of number of products. 2 to the power of number of products into initial reaction. Like that, there is so many formulas are get furtherly. Please note down it.
Sir, left side we cannot see, sir.
Now it okay?
Yes, okay, sir.
Thank you. Yeah, I hope you complete it. Next small component is there, that is the rate constant. We are used every time from the starting of the lesson. One word, that is the rate constant K. What is this rate constant actually? Yeah, this is the not coming from any other pair. Okay, simply this formula. R is equal to what? K into A to the power of N. R concentration of to the power of N. This is only we written every time. Na? Concentration of the reactant to the power of N. Okay, suppose I am taking that the reactant is the A to the power of N. Okay, clear or no? Now, there it is the concentration, N is the what? Rate of reaction. Okay, now the K is equal to how we take it is the ratio of rate of reaction by concentration. Okay, simply the rate of reaction by concentration. Okay, now yes, when the K is equal to become 1 here, the K is equal to become 1 when R is equal to, okay, now yes, there is R is equal to 1. Yes, and order is become 0. Okay, at the power of n, it is become 0. At that time, there is a R K value may get for us. Okay, clear or not, all the students? Yes, here K is equal to R by what concentration of a reactant. Rate of reaction by concentration of reaction. Okay, when these things are unit, when these two things are unit, K is also become unit. Okay, now, hence how to find out the unit of a K, unit value of the K. When we are take a rate of reaction, because most of the intermediate first year chemistry problems on these particular things only. Okay, that will be very good foundation. Okay, now yes, this is a very good foundation for you. Okay, actually no books are contain these type of stoichiometry and rate of reactions in a foundation levels. Okay, clear or not? Yes, generally in a 10th class and everywhere there is about atomic structure and all these make get, but these things are not contained in our regular textbooks. But the foundation level, it will be touched with our textbooks only. Don't take it is much hard thing. Okay, now simple things. Yes, compare with the physics components, it is very easy. Okay, now yes, why? Because the direct formulas are available for us. Okay, and B concentration, how to write the rate expression. I hope you understood or not. Yes, you all understood or not? I hope you understood. Okay, rate of how you write the rate expression and rate law. Simply, you take the whatever the reactants are there in that. Then you have to take a concentrations of that reactants, and that will be taken as a product into, okay, na, rate of constant. And one more thing, very important, order of the reaction. Okay, na, general form you have to should keep in your mind. S small a into capital A plus small b into capital B gives rise to somewhat of products. The small a's are indicate the order of the reactants. The capital A and capital B, when we are write it is in the bracket, that is called a concentrations. Okay, all this together you written as a rate is equal to K into concentration powers of the reactants are only called rate expression or rate law. Got it? This simple concept it is. Thank you. And these whatever the example problem is there. Okay, like that problems are important. Okay, now they're not asked directly what is the rate law, but when it is a double, when the order is the changes, what happens? That things are may ask for you. That is why example number last example is important. Okay, thank you.
अभिवर्धन इसको टाइप